Yellowstone is about to wipe out the entire United States as we know it. The horror could happen tomorrow or in 100,000 of years from now. It's black magic trying to predict when it will blow, but we do know one thing: one day it will blow. However, the real damage goes out to 500 miles if you include volcanic ash, poisonous gases, and that's a ring which goes around 1,000 miles across.
I'm sitting on top of a sleeping giant. Now, if you're sleeping next to an 800-pound gorilla, you monitor every burp, every snore of this gigantic gorilla, because when it blows, it could destroy the United States as we know it.
Welcome back to our channel, where we delve into the mysteries and wonders of our world. Today, we have a topic that will leave you both in awe and a little uneasy. We are about to uncover the terrifying truth about Yellowstone National Park, with insights from none other than the renowned physicist and futurist, Michio Kaku. American theoretical physicist Michio Kaku warned a Yellowstone eruption would devastate the U.S. and change the face of the planet. Yellowstone had its last major eruption some 640,000 years ago and is not expected to erupt anytime soon. However, many experts still worry about the supervolcano's potential for destruction. Yellowstone volcano has the potential to be one of the most powerful volcanoes in the world, which is why experts continuously monitor it. Michio Kaku has extensively studied the risks associated with supervolcanoes, including the one lying dormant beneath Yellowstone National Park. Yellowstone National Park, nestled in the heart of North America, is a place of breathtaking beauty. Its vibrant landscapes, rich biodiversity, and unique geothermal features attract millions of visitors each year. But hidden beneath this serene facade lies a potential catastrophe that could change the course of our planet. Let's not forget about the incredible Mammoth Hot Springs. This geological wonder is formed by a unique combination of heat, water, minerals, and limestone. As hot water rises from deep within the earth, it dissolves calcium carbonate from the underground limestone layers. This dissolved calcium carbonate, known as threathening, is then carried to the surface by the ascending hot springs. The result: these fascinating terraces that captivate visitors with their intricate formations and vibrant colors. It's a sight unlike anything else, showcasing the incredible power of nature. Mr. Kaku went on to add, all you can do is run.
Would there be anything we could do to prepare or to get people out? I mean, how much of a warning might we get with this eruption?
All you can do is run.
One NASA employee believes he has found a unique way to stop a major eruption by feeding cold water into Yellowstone's magma chambers. NASA engineer Brian Wilcox hopes to stave off the threat of a super eruption by cooling down the magma in the chambers inside the volcano. Around 60 to 70% of the heat generated by Yellowstone seeps into the atmosphere, but the remainder builds up inside. If enough builds up, it can trigger an eruption. By drilling 10 kilometers into Yellowstone, the NASA employee believes it would be possible to pump high-pressure water, which will allow the cool liquid to absorb some of the heat before it is pumped out again. Mr. Wilcox told journalist Brian Walsh in the latter's new book In Times the plan could cost $3.5 billion, £2.9 billion. The proposal would have the added benefit of using the steam from the water and magma combo to create carbon-free geothermal electricity at a much cheaper rate than any alternative energy currently available on the market. Mr. Wilcox told Mr. Walsh, the thing that makes Yellowstone a force of nature is that it stores up heat for hundreds of thousands of years before it all goes kablooey all at once. It would be good if we drained away that heat before it could do a lot of damage. Beneath Yellowstone National Park, a vast region of spectacular wilderness visited by around 3 million people annually, lurks one of the largest volcanoes in the world. The Yellowstone caldera, the cauldron-like basin at the summit of the volcano, is so colossal that it is often called a supervolcano, which, according to the Natural History Museum in London, means it has the capacity to produce a magnitude eruption on the volcanic explosivity index. discharging more than 1,000 cubic kilometers to 40 cubic miles of material. To put that into perspective, the 1991 eruption of Pinatubo in the Philippines, arguably the most powerful volcanic eruption in living memory, was rated a 6 on the Volcanic Explosivity Index, making it, according to the Natural History Museum, around 100 times smaller than the benchmark for a supervolcano. Is Yellowstone due for an eruption? Media reports have often claimed that Yellowstone is due to erupt. They claim that because the last eruption of the supervolcano was 70,000 years ago, it's bound to blow soon. But that's not how volcanoes work. This is perhaps the most common misconception about Yellowstone, and about volcanoes in general. Volcanoes don't work on timelines. Michael Polland, a geophysicist and the scientist in charge at Yellowstone Volcano Observatory, told Live Science in an email. They erupt when there is enough eruptible magma beneath the surface and pressure to cause that magma to ascend. Neither condition is in place at Yellowstone right now, he added. It's all about that magma supply. Cut that off, and the volcano won't erupt. Many volcanoes go through cycles of activity and inactivity, Polland said. More often than not, a volcano's activity is a direct consequence of the magma supply. Some volcanoes just seem to have regular eruptions, but this is because the magma supply is relatively constant. Think Kilauea in Hawaii or Stromboli in Italy, Polland said. So where does the idea of Yellowstone being overdue for an eruption come from, then? I suspect the overdue idea comes from the concept of earthquakes, Polland said. Earthquakes happen as stress accumulates on faults, and in many places this stress accumulates at relatively constant rates due to, for example, plate motion. That being the case, you might expect earthquakes to occur at somewhat regular intervals. It is, of course, more complicated than that. There are many variables at play, but for that reason, it makes more sense to say that a fault is overdue for an earthquake. Polland also noted that supervolcanoes, a term he considers somewhat crude and sensationalist, are no more or less temperamental than other volcanoes. So, how do experts keep an eye on Yellowstone's subterranean activity so that, in the case of a major volcanic eruption, warnings can be given? Yellowstone is very well monitored by a variety of techniques, Polland said. It is covered in terms of seismicity and ground deformation. We track the temperatures of some thermal features, although this is not an indicator of volcanic activity, but rather of the behavior of specific hydrothermal areas. We look at overall thermal emissions from space, collect gas and water to assess chemistry over time, and track stream/river flow and chemistry. So what might indicate that a massive eruption is imminent? Having thousands of earthquakes in a short period of time with many felt events would be noteworthy, as long as it was not an aftershock sequence from a tectonic event, Polland said. That seismicity would need to be coupled with really extreme ground deformation tens of centimeters over the same short period, park-wide changes in geyser activity, and thermal/gas emissions. The ground rises and falls normally by 2-3 centimeters 0.8 to 1.2 inches every year, and there are typically 2,000 quakes annually in the area, so it would have to rise far beyond these normal background levels. While Yellowstone is relatively stable right now and has not displayed any unusual seismic activity lately, if it were to erupt, the consequences could be extreme. Volcanologists have suggested that the ramification they are most concerned about is wind-flung ash, which could end up coating a surrounding region 500 miles or 800 kilometers across in more than 4 inches of ash. This could, experts predict, result in the short-term destruction of Midwest agriculture and would leave scores of watercourses clogged. According to the U.S. Department of the Interior, the surrounding states of Montana, Idaho, and Wyoming that are closest to Yellowstone would be affected by pyroclastic flows, while other places in the United States would be impacted by falling ash. Polland added that the effects would also be felt beyond the United States borders. If there were a very large explosive eruption, it could impact the global climate by emitting ash and gas into the stratosphere, which could block sunlight and lower global temperatures by a few degrees for a few years, Poland explained. Research published in the journal Science in December 2022 found that the Yellowstone caldera holds more liquid molten rock than previously estimated. Given that volcanoes tend to erupt only when a vast amount of magma is readily available, should this finding be a cause for concern? This research really just confirms what we already know about Yellowstone, Poland said. Initial findings were that the magma chamber beneath Yellowstone was only 5 to 15% molten. The new research, which uses more advanced techniques but the same data, suggests it is closer to 16 to 20% molten. The take-home message is that the magma chamber is mostly solid, and that means there is far less likelihood of a consequential eruption. I find this result reassuring. However, hope emerges from an unexpected source. NASA engineer Brian Wilcox believes he has found a unique way to potentially prevent a major eruption. His daring plan involves feeding cold water into Yellowstone's magma chambers, effectively cooling down the volatile magma before it reaches a critical point. By drilling 10 kilometers into the heart of Yellowstone, Wilcox envisions a network of pipes pumping high-pressure water to absorb the heat. This innovative approach would not only mitigate the threat of a super eruption, but also harness the steam generated from the water and magma combination to create carbon-free geothermal electricity. It's a groundbreaking solution that holds promise for both averting disaster and advancing sustainable energy. Imagine a future where cutting-edge technology combines with the forces of nature, as humans join forces with Yellowstone's ancient power to secure our planet's future. The proposal to drain away Yellowstone's accumulated heat and tame its destructive potential could be a turning point in our relationship with the natural world. As we contemplate the breathtaking landscapes of Yellowstone National Park, we are reminded of the delicate balance between beauty and danger, awe and apprehension. The journey into the heart of Yellowstone has revealed not only the destructive power of the supervolcano, but also the resilience and ingenuity of the human spirit. So, as we stand on the precipice of uncertainty, let us remember the words of Michio Kaku: all you can do is run. But perhaps, with the convergence of scientific knowledge, technological advancements, and a shared commitment to protecting our planet, we can transcend fear and chart a path towards a safer future. As the sun sets over the majestic Yellowstone National Park, we are left in awe of its beauty and humbled by its potential fury. Let us continue to explore and understand our world, for it is through knowledge and collective action that we can navigate the wonders and challenges that lie ahead.
So a VEI8, or these super eruptions, are you're looking at a volume of magma erupting that's around 1,000 cubic kilometers. So it's a lot of rock coming out of the ground.
Cubic kilometers. So 1,000, if you take the cube root, you get how big a cube would be on the side. So 10 kilometers on a side. So for the American audience, that you've heard of 10K runs, that's about 6 miles. So imagine a cube 6 miles across, deep and high. Damn. And that's how much lava came out. That's crazy.
Yeah.
As we reach the end of our expedition into the depths of Yellowstone National Park, we stand in awe of the immense power that lies dormant beneath its tranquil surface. The supervolcano, a sleeping giant of unimaginable force, serves as a humbling reminder of nature's unpredictability and its capacity to shape the course of our world. While the potential for a catastrophic eruption looms over Yellowstone, we must not succumb to fear. Instead, let us embrace the knowledge and understanding we have gained from dedicated scientists like Michio Kaku and visionary thinkers like NASA engineer Brian Wilcox. Their tireless efforts to monitor, study, and devise innovative solutions inspire hope for averting disaster. The audacious proposal to cool Yellowstone's magma chambers with high-pressure water holds the promise of taming the volcanic beast. By harnessing the forces of science and engineering, we have the potential to alleviate the accumulating heat within the Earth's depths and prevent a cataclysmic event of unprecedented proportions. Imagine a future where humanity collaborates harmoniously with the planet, utilizing our collective intelligence to safeguard against natural threats. The ingenuity and perseverance of our species have brought us to this point, where we dare to challenge the very forces that shape our world. As we bid farewell to Yellowstone, let us carry this newfound understanding with us, fostering a deeper respect for the delicate balance between nature's beauty and its potential fury. May we continue to explore, to learn, and to protect, ensuring that the legacy of Yellowstone National Park endures for generations, not just as a testament to Earth's splendor, but as a symbol of our unwavering resolve to safeguard our planet's future. Join us again as we embark on future adventures, unearthing the mysteries and wonders that await us, ever mindful of the fragile harmony that exists between mankind and the forces of nature.